Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Multi-Level Fuzzy Inference System-Based Handover Decision Model for Unmanned Vehicles. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the protocol design for the unmanned aerial vehicle handovers. So before starting the video, let's talk about what we'll cover into this video. In this video, initially we will talk about the application areas where these unmanned aerial vehicles can be implemented and the protocol of the handover that we have designed can be used. Then we will talk about the code that we have designed, that which file has to be executed and what are the software and library requirements for that. Along with that, we will talk about that what are the current systems, what are the problems identified in them, and what is the proposed method and how it is handling those problems. Finally, an experimental outcomes and the findings will be discussed in brief. So let's talk about the application areas. So handover schemes is basically when the device is moving from one place to another and it is mobile, and then the connectivity with the network must remain same. So in those domains particularly handoff is there. So one of the application area for this is the mobile application. Second is the unmanned aerial vehicles, especially in the domain of the military surveillance or the surveillance purposes and many other. Currently many of the people are using their drones and all, so when they need to communicate with the devices, obviously there is a need of the networks, and those networks get handover from one cell to another by the use of these handover schemes. So in the domain of UAVs, unmanned aerial vehicle, either it will be in military or the social or the defensive or the surveillance, in every of the domain these handover schemes can be beneficial. So especially in the daily life we are using with the mobile communication. So now let's talk about the code that we have designed and how to execute it. Here you can see we will give you the folder name code under which there are a number of files. So to design this particular code we have used the MATLAB software. So you must have the MATLAB software with you, in which the MATLAB version that I am using is 2019. So you can use 2015 or above to execute this code. So in order to run the code, you just need to go to the main folder, and then you just need to copy the path of the folder. After copying the path, you just need to go to the MATLAB, and here you just need to paste it. When you will paste the path and press enter, you can see all the files those were there in the folder are visual here. So here are two files, one is base drone code and second one is proposed drone code. So we have implemented the base paper as well as the proposed one in order to demonstrate that our scheme is improving. So you just need to open these two files by double clicking on the files. So in order to run the code, you just need to select the file and you need to run the code. So whenever you are running this code, you just need to click on this green button and the code will start executing. All these files will be start processing. So in the meantime the code is executing, let's talk about that what exactly the problem is, what people are doing. So we were referring one of the paper, this is one of the example that they have designed intelligent handover scheme from the drones using the fuzzy interface system. So fuzzy interface system is basically the fuzzy logic systems. So what they have done, they have implemented it for the domain of the Wi-Fi, WiMAX or the cellular networks where the devices are moving, the mobility based networks are there. So what they have done, they have used the fuzzy logics controller that is taking few of the inputs as a system to take the decision. So this was a system that they have designed in which the uh, initially parameters have been taken from the device, and then on that behalf they have considered two of the parameter, one is coverage, another one is the speed limit, and on that behalf they are taking the decision, that estimation level in terms that whether the uh, handover is to be given or not. So here you can see this is the reasoning layer where whatever the data will be given, that will be in the terms of coverage and speed limit. Then the rules are given to it on which the estimation is being calculated, and finally on the basis of the estimation they are deciding that whether the handover is to be given or not. So the fuzzy that they have designed is basically on the basis of two parameters. So the problem that we have identified is the coverage and speed limit are not only the factors on which the handover can be decided. There are certain other parameters, those are helpful in deciding the handover and can stable the network for the longer period and can make a appropriate decisions for the handover. So all the information they have given for these two parameters was there, so we are referring that. So the final results they have calculated for the two scenarios, one for the random, another one for the state movement, and finally the calculation is being in the probability of the decision cost. So we have identified that the parameters they are using is quite less. So in order to propose a system, what we have done, this was the base paper outcomes that we have designed, in which the base paper system has been designed, in which two parameters have been taken, 8 rules were there, estimation is calculated, these are the fuzzy membership function, and then compared that what was the results with the random and the straight in terms of estimation level, in the terms of the PDR, packet delivery ratio, packet loss, throughput, and finally yes, the with the different movements, right? So this is what we have calculated. The whole code is being designed in which the initially fuzzy system is being designed, rules has been given as per the base paper, and on that behalf here we have taken the scenario. They have not given that detail of the scenario, so we took that, that's why we have implemented it in our scenario. So here you can see the area that we have considered is 100 by 100, base station is at the center, simulation time is for the 40, then the packet transmitted is the 512 bytes, then the estimation is being processed, and we have run the simulation for 5 times for the straight random section. In the random section, the location of the device is being randomly deployed, and with respect to the base station, the parameters of speed and coverage is being calculated and then evaluated with the fuzzy to get that whether what exactly the delay or the estimation level is received from the fuzzy. Rest of the parameter we have calculated as per the packets, that how much it need to be communicated and the simulation time and everything. In the second scenario, the as it is a straight line, then we just kept it in a straight line by moving in a particular direction, not randomly, then calculated the same scenario, and finally the results has been evaluated. In the proposed scenario, what we have done, we have given a new method in which we have designed the fuzzy with extended parameters. So let's see what extended parameters we have considered. So I'm just going to run this code. You can see we will get the fuzzy system that we have considered for the proposed method. So in the proposed method, instead of only coverage and the speed, we have considered multiple parameters. So these parameters are coverage, obviously, speed limit, because these are the two parameters from the base paper. Then how much cost it will take to move from one cell to another, that which will be the best probability, because handover getting scenario is like if the multiple cells are there, it is easy to move to any of the direction, but cost is also one of the factor. Connection time, how much time it will take to get connected to that cell if the handover is to be given. Then security, whether that particular cell is secured or not. So we have calculated these 5 parameters, extended the parameters, and then given around 160 rules for deciding the probability of giving the handover. So what we have done, we have designed this system by using the FUZZY fuzzy. So you can see here, you can design whatever the system you want to design, or even whatever the system we have designed, I can show you that. So you can just import it from a file, and the FIS file that we have designed, you can open it here. You can get the details of everything here. You can see these are the cost functions. You can clicking on any of the parameter, it will show you what exactly the parameter range you have given, which method you have used, the probability ranges and all. Even for seeing the rules, you can just click on the center. Here you can see what these are the 160 rules that we have given for the proposed method, and finally the probability is given from 0 to 1, that is very low, medium low, low, medium high, and very high. So on that behalf, whatever the rules we have given, it is going to decide. So I'm not going to change any in the fuzzy system that we have designed. So you can see the initial system has been initiated, then the scenario has been considered by varying the different scenario where speed is changed, cost is changed, all these factors has been considered to be scenario. So as per the scenarios, the same randomization and the straight line communication has been conducted and evaluated all these 5 factors for the individual node present in the network, and finally we have evaluated the average, estimation, packet delivery ratio, throughput, and the delay. So all these factors are important for the calculating the results. So we have calculated the proposed results and then compared it with the fuzzy base results that we have already saved in the base results. So when we have run that, you can see these are the results that we have achieved. This is the system that we have designed. These are the membership functions for the proposed parameters, and this is the membership of the probability that will be extracted out from the fuzzy system. So what we have seen for the estimation level for the random and the state is less in terms of our proposed method, because as the estimation will be less, or the handover will be minimum, the system will be more reliable. So you can see by doing so, because obviously we need to switch less, so the stability of the network will be more. So the packet delivery ratio is more, packet loss is less, here throughput is more, and the delay for the connection among getting the handover is also less. So in these scenarios, when extending the parameters, you can see the proposed system is performing effective in comparison to the traditional base method which we have considered from this paper. So further modifications are still possible. For that you can contact us directly and stay tuned to our network. PhD research, master's research, or the industrial based applications can be designed by this. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.